Okay, by raising a hand, can someone remind us what is the mole in chemistry? Like, what is this thing that we're going to use all year long? Matt, what is it?
It's a number that we use, and it's like a mole of proton because it helps us see atoms and understand.
Yeah, so take these things that are so small that we can't see, group them together in a huge number so that we can work with it, measurements, so on and so forth. Great, thanks, Matt. Have a smiley face for that. So last time we talked about the relationship. So I'm going to draw a little map off to the side here. If you want to put this somewhere in your notes, you're welcome to, as if it helps you. Okay, so the mole is a connecting piece to everything in chemistry. Right? Once again, our catchphrase in AP is when in doubt, mole it out. If you're doing a problem and you're like, I don't know what to do, go to the moles because that probably is the first step if you're not already there. Okay? The problems we did last time connected moles to particles, atoms, molecules, things like that. Okay, so the mole is connected to, I'm just going to call them particles. Once again, particles could be atoms, molecules, compounds. They all fall in that category. Okay? What connects the particle to the mole, or how many particles are in a mole? 6.02. There it is. 6.02 times 10 to the 23rd, which is Avogadro's number, right? Always true. Okay? Now what we're going to look at is how the mole connects to grams. If I have a mole of something, how many grams is it, or what's it called? There it is. Man, it's hard with math, Con, until I get to know your voices to tell who gave answers. So, Max, I think that was you, right? No? See, I just hear it come from a direction, but some of your voices I know because I know you from other things. But okay, molar mass. So that's what connects it to the mole. So let's look at this problem here. So it says, I'll stand back so I can read it. Calculate the number of moles. So first thing, circle what you're finding. So circle number of moles. Put a circle on it. Of glucose in 5.380 grams of glucose. Okay. All right, so we have our grams, and I want to get to moles. So set up your conversion. Okay. The unit we're leaving goes on the bottom. The unit you're relating it to goes on the top. So in this case, a mole. Then we said the thing that connects those two is the molar mass of it. Someone by raise a hand remind us, how do I find the molar mass of something?
You do the atomic weights of all of those, multiply them out.
Good, so we gotta add them all up.
180.15 if you don't feel like doing it.
So that's what we get when we add up all their individual masses. Now, why did I put that number on the bottom of my fraction and not the top? Kimberly?
So you can cancel out the units, and we can end up mole.
Yeah, because that's what makes it a true conversion, right? 1 mole is that many grams, right? You should be able to turn your conversions into a sentence. If the sentence doesn't make sense, you've done something wrong. Okay, plug that in, and I got about 0.02989 is what I got. Moles of glucose. Questions on that? Yeah, Kimberly.
I was wondering what decimal place you would like it rounded to, because on the homework, the ancestry was different, because it was either tenths or hundredths.
Good question. After we do the rest of these practice problems, we're gonna learn the rounding rules for AP, because it's a little longer than just a one-word answer. So, but yeah, great question. Any other questions?
So can you draw like the slashes, like what you're canceling?
Sure. Yeah, if you want, like you can show like, okay, the grams are canceled, so the only thing left is the unit that I want. Both those blocks there.
I don't know, it all just seems weird because it seems like I can't add 1/3 and 1/4, but like, it's just weird that we're at, I don't even, this didn't make sense in 8th grade and it doesn't now, but that's okay.
So the thing that, tell me, and we'll keep doing it, so if it doesn't make sense, just give it time to sit, right? I can't remember where I heard this quote, but I think it's a really good one where it says that sucking at something is the first step at getting good at it. So if you ever feel like you suck at chemistry, it's okay, because it's the first step. So I'm not saying you suck at it, but if it's not sitting well, it's okay, we got time. Is it just the crossing out that's confusing you, or the...
Like, I did the whole homework and got the right answers, but I didn't write any of the work.
So the process, as long as you're understanding how it's converting, that's fine. That's the biggest thing, so.
I don't know.
All right, we'll keep going, and if we get stuck, then we'll figure it out. So, okay, any other questions for now? Yeah?
When we're rounding, what should we round it to? Like with the word?
So hang on, and we'll answer that in a moment, because it's not a set answer. We're going to learn about, some people have learned it in physics. We're going to learn about significant figures, and that's how we round things. So, anyone here learned about significant figures before? A few. I know sometimes it's taught in physics. So, okay. Let's have you try with your table buddy the next problem. Ready, set, go. Oh, calcium nitrate, by the way.
How nice of you.
Is that? Sorry.
So that was on the homework.
It was on the
So we
homework.
already calculated it. What was it?
It would be 1 mole.
We can just look it up.
We're trying to calculate.
Calcium nitrate.
160. No, but if you have to.
At 148.
So
I have 148.2. What do you have? Oh, what do you have? Because what is it?
Put your number that makes you guys right. What do you know?
So yeah, so you guys are right then. What did I do?
Moles per mole. What are you trying to do? So we want to know if I have that many moles in it, how much is it going to weigh, right? So we need to know, well, how much does one of these weigh?
Plus 6 times 60.
Good. So we find that by adding it all up, right?
Why times 3? Well, yeah, but I did it times 6.
Okay, that makes sense.
Okay, pause for 1 second. So the unit that you're changing from should go on the bottom. There you go. If anyone needs to borrow anyone need to borrow a calculator today because you don't have one? Okay, so what unit are we trying to change it into?
Yeah, I have the right work, I just must have typed it in my calculator wrong.
That's it, right?
Because I'm like, I wrote the same thing you did.
Good, so if I combine mass,
Okay.
of all of them,
For sure it's 164.
Yeah. So this is more.
So in our notes packet, or we had to do
one mole.
Yeah, the thing is, yeah.
So with this one, we just talk
Well, yeah, it's always over one.
So it was 164.
So this question was giving
Why did I just bother with
what's that measurement? Grams, like the 164, what's the unit?
Okay.
64. Oh, atomic mass. But I feel like when it moves to like more complicated measures, you don't know how to do it the right way, you know?
You start with it, this stuff.
Yeah.
So we're
It just takes me a second to think.
I think we did a lot.
Okay, you got 71.1 grams as your final answer, or around there. You can have a smiley face. If you got it wrong, let's backtrack and see what went wrong. No, but they should be here by next time. So just keep tracking your notes still. I know. Start of the school year, copies are kind of crazy. Okay, any questions so far? Okay, for smiley face, is there anyone who got it wrong that's willing to share what they did wrong so we can learn from mistakes? Thanks, Max did so good to learn from failures. It really is, because then he's being like, he's helping you all out so you don't have to do stuff. Okay, Max, what did you guys do wrong?
We just calculated the more math wrong, so we have like just a teeny bit off, but we got totally different.
Great, and that's a, like, this sounds silly, but that's a good mistake. Because you understood the setup, you knew what you were doing, you just made some little math error here. Now, this is an example, guys, of why showing your work on the non-multiple choice section of the test is valuable. Because you may actually still get points for that, but if you only had an answer, it'd be wrong no matter what. But if you showed them and they could see, it's not always given, like they don't give partial points, but there are sometimes setup things that you can still get points for. So, thanks, Max. Okay, any questions before we go on to the next step? Okay, let's look at our next problem here. Right here. So this one says, how many atoms are in 3 grams of copper? So as a visual here, pretty much what we're finding is we're finding how many atoms are in a penny. Theoretically speaking, if the penny was fully copper. Right, because pennies aren't, if you didn't know, pennies aren't fully copper. They have zinc in the middle, right? But if it was, how much it would be, okay? So once again, circle, what are we trying to find here?
How many
Atoms, so circle that word atoms. What do I know about my substance? Good. I have 3 grams of copper. So if you take a look at our map here, everybody, really quick. I'm in grams. I'm going to particles because atoms is a type of particle. This is going to be a 2-step conversion. Okay? In the world of moles, you can't take airplanes and fly places. You have to drive through the moles. Okay? So, step 1, I'm going to go from grams of copper. Oh, let's change colors here. Oh, fingers. To moles of copper. Okay? Next step, I'm going to then go from moles of copper and convert that into atoms of copper. Okay? Set up your pathway and then plug in the relationships. So moles and grams is connected through molar mass, which for copper is 63.54, something like that, to 1. And then 1 mole of copper is 6.02 times 10 to the 23rd atoms of copper. Plug it all into your calculator. And I got 3 times 10 to the 22nd atoms of copper.
So we're just multiplying it by 1 over and changing the units.
Yes. Yes. No, that was a beautiful sentence because that's literally how conversions work. What's important to recognize, everyone, is that this fraction right here, independent of the problem, is always true. Right? This is always a true statement. This is always a true statement.
Yeah.
That's the only thing that ever would change in a problem. You'll know you're getting good at conversions when they start feeling extremely repetitive. When it feels like, I just did this, you're figuring it out because it's literally the pattern doesn't change. So, any questions? Yeah, Kimberly.
I might have typed it in wrong because I got like 2.8 times 10 to the 23rd.
23rd. Do you still have it on your calculator?
I just did. Did you round? Does it work? I think so.
You have the same one. I just rounded to 3. Yeah. Yeah.
I was so confused. I was like, I've been literally doing this for a year.
Yeah, you just wrote it down wrong. So, okay. I think most of you have already started, but if you haven't yet, try the next problem with your table buddy.
Okay.
What was wrong with hers? Because we all got I rounded up.
Copper is the molar mass.
2.8 times 10 to the 22 is the same thing as 3 times 10 to the 22. We'll talk about why. It's the same thing.
And molecules are kind of like atoms. It's just a bunch of atoms.
What is it? Keep typing it in.
We found it.
Yeah. Yep. Yep, so they fall in that same category of particles.
Okay.
When you're done with this practice problem, give me a pencil drop so I know you're done.
Oh, I wrote MOL as an abbreviation for molecule. That was a bad idea.
Oh, yeah.
Yeah, why is that a thing? I was doing the homework on it, like,
It's one of those things that I'm like, I gotta talk to the American Society of Chemistry or something and be like, what is it?
Molecule is MOLE.
So Miss Obizo made up a molecule abbreviation if you want to use it in this class. I write Hules.
Cool.
Oh, that's what that was. I was like,
Was it on the? It just, yeah, because I guess I'm too lazy to write molecules. I just write Hules instead.
is ML an abbreviation?
Milliliters. I know, that's the problem, is we're trying to think of all the others, it's like we can't use.
They should have used.
Why did they do that? They should have named mole like something.
Just leave mole as is.
Yeah.
I agree.
23rd.
Yeah.
That's what it should be. Like a
Moles
that's an avocado with like a pear with a hole in it.
These are values.
that's probably better.
Okay, that's the answer.
Wait, what did you get? Okay, good. Time to do it. Well, yeah. But, this is the only part that's weird to me. No, that's just saying this is a mole.
Oh,
That's
that's
literally.
what this yellow is.
Okay.
Right here.
That, you just have to put the one on the bottom
It's
so you
just
can
as
cross
you
out the
use
E.
rounding rules are a little longer than the one.
Mine says either the 23rd and yours says either the 22nd.
Oh, when you use P, you don't put the tense.
Oh.
Or the times. That's why they use that.
Oh, you don't put the
I wondered
times
what.
either? That's all.
Yeah, if you have it like that,
The
it's not
same
a
number of
shortcut.
buttons is
Yes,
what
you
we
have
use.
to 6.02.
So that's saying 24.
Yes, that's why you have an extra digit at the end.
So just write 6.02 times, or no times, just E to the 20. Yep. Okay, yeah.
I see now, especially on last time now makes sense. Because the way you were typing it, it literally is the same amount of work, right?
Yeah.
Man, it's so hard to stay hydrated when you have mask on. I'm way behind schedule.
Good one.
Okay.
Okay, how are we doing? Are we ready to hear an answer? Anyone need more time on their own before I give an answer? Wait.
I don't know.
I know, I love your colors. Because then you can cross it off.
Okay, if you got 1.75 times 10 to the 22 molecules, you are correct and can have a smiley face. Any questions? Nope. But they're coming.
She doesn't like that question.
I know, huh? It does, because I don't have them yet. But they should, yep, next time. So, okay. Any questions? All right, so at this point in our notes, we're gonna change things up a little bit to the original packet I gave you. So the next page, and the back side of it, and the next page, not that side. So this entire next page you could rip out. We're not covering it.
We're just throwing it away.
We're not covering it again until Unit 4, and Unit 4 is not going to be pink, so because they're all different colors.
From exercise 3.
We're going to recycle. Recycle. Okay. Okay, shoot them in. Don't hit me. Oh my. Oh, good job. Oh, sorry, I was catching another one at the same time. Oh, you're so nice. Okay, thank you. Okay, we are gonna learn it eventually, but I think it fits better in another unit, and so I think it'll be better for us that way. On that same note, in your homework packet, if you want to go to that really quick.
Let's rip out the
Okay, so some of these you can't rip out because it's like double-sided or something we do need. But if you want to cross off the first page of 1.1b, I'm going to give you a different 1.1b today, but that one we're doing later. Okay? And then the entire next page we don't need. So you could get rid of that one. Oh, or that page. So the next two pages we don't need, but you do need to keep the one that has 1.3 on the back of it.
But we can X out the front.
But you can, get rid of the front side. Does that make sense? Yeah, you don't need percent yield.
And this is the next time you take that one out.
Working on our skills.
Yeah.
Oh,
Still upload it, you have to.
Oh my, good thing you run cross country.
That is the reason why.
That's okay, there's a reason I coach cross country. Any others?
I don't have any can.
Ooh, off the rim. Oh, that was a good round. Nice. Okay. Good? Are you throwing that dagger? Okay. Are we good? Can I put the basket away? Okay, take a look at that yellow paper I passed out. Pass it down if you haven't. And let's answer the question of round. Okay, I'm going to turn this off. Okay. So, okay, here's my analogy for us, okay? Let's say I have a stick, and I want to measure the length of my stick for an experiment, okay? There's my stick, okay, right? I go and grab a ruler, and this is what my ruler looks like, okay? Okay, so on and so forth. Okay? That's my ruler. Based on my stick, based off my ruler, how long would you report this stick is?
5 1/3.
So I hear some people saying, can we use decimals, not fractions?
5.33. That one looks good.
Any others? I don't know what you said, Bryce, but I just threw some numbers in there.
I said 360.
Oh. I heard the numbers, I just changed the order.
Very precise.
Okay. So, first off, obviously, even right now, with measurements and labs, we have number one problem, we're human. And so there's a problem of human error with all measurements, right? Other problem is equipment error. The equipment we use in the lab is only so accurate, okay? Let's say this ruler, for example, is not very accurate, meaning it doesn't give you very much information. Let's say I had a ruler that instead of looking like this, now looked like that. Now I'll draw a line because I know it's kind of, I should have drew a bigger picture. That was pretty straight.
That's in between.
So based off now our ruler, how would our measurement change?
5.364 looks pretty good.
So would we keep this measurement anymore?
No.
Probably not, right? So the more precise your equipment, the more precise your measurement can be. But there are rules in how precise you can be. And this is what are known as significant figures. Significant figures help us understand how accurate of a measurement we're taking, and it has to be to a certain amount because otherwise you're just making stuff up. Like Bryce, no offense. Okay, so the rule with measuring, so when we go into the lab and do experiments, you have to report the correct number of sig figs, or literally you are lying on your lab report. Okay, the way you report the correct number of sig figs is you always list the exact known digits. Okay, so going back to before I added the little lines, what did we know with 100% certainty about our stick? Okay, so this right here is what we would call a known digit. We know it with 100% certainty. Do we know anything else for sure? Without the little dashes yet.
No.
So without the dashes, we don't know anything else. All measurements you take get all known digits, plus you do get one logical estimate. So you could say 0.4, you could say 0.3, but we can't have anything more than that, because you don't know really if it is that. So when we're taking measurements, you get to list everything that's known plus an estimate. So if this is now my ruler, what do I know with 100% certainty?
5.
So I know 5, I know 3, and then you do get an estimate. And that could vary, right? So whatever, 6. Okay? And then the more precise your equipment becomes, the more digits you can list. This is the idea of what significant figures are and why they matter. Now keep note of a few things. Number one, if you're using a digital piece of equipment, right? Like a lot of the stuff we'll actually use in AP are just digital. Like it'll just show on your screen the temperature or different things. You don't add numbers to a digital one, right? Because there's nothing to estimate. You just take it as is. Same thing, if something is an exact known value, it doesn't count for significant figures, such as counting something, right? If you're just counting, that's an exact number, right? It's not anything that needs to be estimated. Okay, now don't say it out loud. Think in your head for a second on this line of sig figs. Can anyone tell me, so don't say it out loud yet, so everyone can think, what would be the difference between these measurements? So just think to yourself for a second. This is where we differentiate a little bit between math and science math. Because your calculator will interpret all those numbers the same. But scientifically, someone willing to share what's the difference? Yeah.
So for the second one, there was a number probably less than 5 that came after that, but you were showing that I did rounding. I rounded to that to 5.0, so it was probably like 5.03, 5.02. And then the third one was like 5.003 or 5.002, so it's showing what you rounded to.
Good. Any others? Evan?
It could also be like 4.99, so rounded up to 5.
Yeah, good. So yeah, I could have rounded that way. Yeah, Max?
I think the zeros are maybe showing that, like, you know that there's nothing in that place value.
Yeah, it's really saying like, no, this is 5 feet. When you just report this, technically that could be anywhere between like 5 feet or 6 feet, right? That's me like looking at the table and being like, that's about 5 feet. True, but it doesn't show the precision in your measurement, right? So the more digits we have, the more we know something. Now the problem with rounding is your calculator sees these all the same. But when we do math with our measurements, our final answer has to show the same number of significance. We can't report a final answer that's more significant than what we measured, or vice versa. You don't want it to be less significant than what you measured. So first thing we're going to talk about is how to identify what counts as significant when you don't take the measurement. So this is how you do it when we go into the lab, but a lot of times in AP we're given problems. So we need to interpret, okay, when it's given to us, what is considered significant? So take a look at the top of your paper here, and there are 4 rules to identify from a known number what counts as a significant and what doesn't. Now keep in mind, when we use this word significant, it doesn't mean that we get rid of the numbers that aren't significant. It just means they don't show accuracy in the measurement. Okay? So rule number 1 is any non-zero numbers are always significant. That makes sense, right? If it's not 0, then it's a measurement. So those count. Okay? So in a sense, this measurement right here, we would say has 3 sig figs. Because the 5 is significant, the 3 is significant, and the 6. Okay, the estimate is still counted as significant. That's why it's listed. Okay, rule number 2 is zeros located between non-zeros are significant as well. So for example, if I had the measurement of 5.06, the 5 is significant, the 6 is significant, and the 0 is in the middle, so obviously it's part of the measurement as well. So that would still have 3 sig figs. Okay? Rule number 3 talks about trailing zeros. So So zeros that come after a number. Zeros after a number are only significant with a decimal added. So once again, kind of a weird thing between chemistry, math, and maybe what you're used to in math. This number and this number and this number all mean different things. Okay? In this first one right here, the 5 is significant because it's not a 0. But because there's no decimal place, these zeros are just holding the place value and they don't count as significant measurements. So we would say that this measurement only has 1 sig fig. This is a way to show someone else who's reading your measurements, no, these are significant, I knew those, and so now this has 3 sig figs. Don't say it out loud, but show me on your fingers, how many sig figs do you think this would be then? You're showing me a 4, you are correct. So, anything that continues, once again, is narrowing down that precision of your measurement. So this would have 4 sig figs. So I know it looks weird, like to have a decimal but not put anything after it. But you're going to see that at times and use it at times because you can't just throw a 0 on there because now you're changing your measurement. Okay? All right, rule number 4 talks about zeros that come in front of a number. So, like, let's say, if I have the number 0.012, zeros to the left are always placeholders. So they are not significant. So that would only be 2 digits. Okay, let's check your understanding of what I just told you. Go to the bottom of the yellow paper and do practice problem number 1, A, B, C, and D. You can talk to your table buddy if you'd like.
Oh, I did ACD.
You skipped one?
D is a little weird. It's like the number that. But then that actually number. But then this one has 3 of the numbers. The number what it actually is. Then that's only like 2. So like, is it 2 or 3?
Yeah. But there wasn't just. It might be 6 distinct.
I think it's just 2.
Then it would just be 2.
Yeah, but like the number 3.40 has 3, but it's probably just 2 because that's what the number actually is. It's just weird. One was making me that money on it.
Okay, are you ready to check it? Give me a wave if you need in a few more seconds. Okay. Okay, you're gonna hold your answer of how many sig figs for each one I point to, but keep it like under your chin so like other people can't see, so everyone can kind of like think for themselves, okay? Okay, show me on your fingers how many sig figs does this number have? All right, the correct answer is 2. Why? Yep, zeros to the left are always just place values. They don't count as significance in the measurement. So only those 2 are significant. Okay, very good. You can have a smiley face, by the way, for every one of these you get right. Okay, show me on your fingers for B. How many do we think? Show me for B. Some people are flickering their fingers. This, This, maybe that. Okay, the correct answer is 3. So I think we all understood that the 3 and the 4 are significant. Do we see why that 0 is significant?
Yeah. But like the actual number is like 3,400.
Right. So if I change my scientific notation, that's how it looks, right?
Yeah.
Scientific notation is a way to show significance of zeros and not other zeros. So we needed to show that these 3 were significant. I can't show that by leaving the number like this, so they had to change it into scientific notation. So, great observation. Questions on that? Kind of another thing too is if scientific notation gets rid of the zeros, like if I were to change this number, right? So I could change it to 5.5 times 10 to the what? 1, 2, 3, 4, 5, 6. Right? It gets rid of all the non-significant digits. So, okay, very good. Show me on your fingers, how many does this number have? Very good. All 5 are significant there. And last one, show me on your fingers. Good. All of them are significant there as well. Good. Questions so far? Okay, so now let's talk about the round. Oh, sorry, Isaac.
I was just so confused why it's not 4 digits on the second one and it's 30. Right, 60.
On this one?
Yeah.
So the reason why they wrote it like this is when you write a number in scientific notation, you drop anything that's not significant and you leave what is. And so the zeros after the decimal are significant, correct? And so that's why it's written like this, is to show, hey, this is significant, but there's another 0 on there that's not. Do you see the difference?
Yeah.
So if it was only like 2 sig figs, they would have just written it like that and not put the 0 on. That would be only 2 sig figs. Even though mathematically, it'd still be the same number in the end. So, did that answer your question?
Yes.
Okay. Yeah.
So writing anytime you're trying to figure out how many sig figs there are with scientific notation, you can always just count the digits.
Yep. Yeah. Yeah. Cause that. Yeah. If it's listed in scientific notation, they all have to be significant because otherwise they would group
Not
it in
be
that times 10. Yep. Yeah. Good connection. Any other questions? Okay. So because our calculators, right, would read a lot of these numbers the same, that's where the rounding comes into play. So take a look at the bottom at number 2, and let's talk about the rules for the math side of it. Okay, so A has that we're going to take 10.3 and times it by 0.01345. Can someone type that in for me and tell me what we get? 138. 535. Okay, so this is what our calculator gives us. We have to round, though, to show the accuracy of the measurements we used. So there's 2 sets of rules. One for when you're timesing and dividing, and a different rule for adding and subtracting. Okay? The rule for timesing is you go off the least number of sig figs and round to that. So, this measurement right here has how many sig figs? 3. Okay. How many sig figs does this number have? Yep, 4. So our final answer only gets 3. So, is the 0 significant? No, so that doesn't matter. So I need to keep this one, this one, this one. Now, the final digit you keep, you do look to see if we're rounding. Since it's trailed by a 5, it would round up. So your answer in sig figs would be 0.139.
Yay.
So it's okay if we include the 0 before the decimal?
Yeah, because it's not significant. So, yeah, good question though. Comment.
45 zeros. Lots of zeros.
Yeah, you could put lots of zeros in the front if you wanted. Okay, questions on that rule? Okay, now if I'm adding or subtracting these numbers, the rule is different. Now, I'll be honest, we times and divide a lot more in chemistry, for whatever reason, than we add and subtract. So this is the rule you should default always back to pretty much, but there is a separate rule. So if I add these two numbers, I end up getting 10.31345. The rule for addition and subtraction is you go off the least accurate place value. So you look at the place value of your measurement. This measurement went to the 10th place, right? This measurement went to the something place, 100,000th place. So obviously this is the least accurate in terms of precision. So that means my final answer only gets to go to the 10th place as well. So I have to cut my number off after that. Check for rounding. This one doesn't round up. So your answer would be 10.3. Now, it is okay if the math brain inside of you, that bothers you a little bit. Because I get at first look, does that answer seem weird with this problem?
Yes.
Why? Yeah. But scientifically, it actually makes a lot of sense. Because of how small this number is in comparison to that, is this number actually really changing? Very insignificant, and it's so insignificant based off our measurement, it's not even listed. Yeah, Evan?
So if it was just 10, not 10.3, would the answer just be 10?
Ooh, let's think. So if it was 10, oh, does it have a decimal or not a decimal?
No, that's.
Oh.
This is fun.
So if it was like that,
Yeah.
so then your answer would just be 10 without a decimal as well.
Okay. Also, can I go to the next one?
Yeah, go ahead.
But then if it had a decimal,
It still would actually be 10, but then
because
you'd
it would
also
still be
have,
no decimal things.
yeah, you'd put a decimal there too. So that is how we round in AP Chemistry, is we have to take into account significant figures.
Okie dokie.
Now, we're going to obviously do sig figs, think about sig figs all year long, but it should never be a major stress or time consuming thing for you. If it is, then we just need to move on. Because when it comes down to a big picture wise, it's a very small, there's 1 point on the entire AP test that's about sig figs. 1 point. So if you do your sig figs wrong at the end of the year, you're only going to miss a point. But it's not a hard thing to think about, but once again, it shouldn't be something that you're stressing about either. So the main place we need to be very careful with them is when we're taking our own measurements in the lab. When you're doing a measurement, you got to make sure you report your correct things on your report and stuff like that. So, questions on sig figs? Okay. So, perfect. Okay, we got about 14 minutes. Okay, so we're actually, this is kind of a miracle, doesn't happen very often. We're going to get started on our homework assignment in class. Okay, so here is your new 1 B that you're doing. It's all about conversions, so on and so forth. I do want you to think about sig figs as you're doing it as well. Okay, other homework assignments, so just as a review, so you have your AP Classroom quiz. I would do this last in my list of homework, because this is kind of a way to check your understanding of everything else, right? And your time, you don't have other resources. So do the homework, check your answers, make sure you're doing it right. There's a quiz assignment on Canvas about sig figs. It's 20 questions, you get 5 attempts at it, but it does generate new questions each time you take it. But they're the same topics. So you should be able to see what you did wrong and then hopefully be fine the next time. And then one small reading section, it's 2 pages, people, that's it, about sig figs. So, questions on the homework? Okay, so until this is done and the safe thing is done, you shouldn't be on your phone and you shouldn't be doing anything else. Okay, just a reminder in this class, if you get on your phone when you shouldn't be, you violate your right of retaking the test. So just leave it away because I guarantee you we'll rarely ever have time where we're not doing something. So, okay, work with your table buddy. Let me know if you have questions as you work.
Can I just go and be on time in class?
Yes, you can head to
Cool.
your
I've never been on time before.
class at your other school. I want to keep this one first for me, just because I want to make sure we don't have any questions on this. But if you get this done, then yes.